Yes.
Okay.
Yes.
Okay. All right. Thank you. Thanks. So today my presentation is going to be on an integrated approach to functional safety analysis according to ISO 26262 standard. And I'm going to cover a couple of topics to start with a brief introduction. So that's introduction to ISO 26262 itself. And we will get down straight into hazards and how to perform safety goals and how to derive safety requirements. How could we go ahead and create safety architecture, FMEA, FMEDA, and diagnostic coverage, fault tree analysis, dependent failure analysis, etc. Rather, I would keep my slides very minimal. I don't plan to talk too much on the slides. So what I thought might be interesting to this group of people here today to quickly see how this kind of activities can be done in a live example. So I thought rather than talking too much on the tool or presentation, I took up this example for my workshop on functional safety analysis of a battery management system. So we see that battery management is now becoming quite important with many of our industry colleagues. So I thought probably this topic would be interesting to you as well. So I plan to show more of how do we do this kind of safety analysis and what's our approach and how a good tool with an integrated approach for the entire safety analysis could really help you speed up your development as well as analysis efforts. Talking about the life cycle with ISO 26262. So in the last session, for those of you that have attended the session from Mr. Shiva from TruthSuite, so he has given an excellent overview of ISO 26262 process all the way starting from part 1 covering all the way up to part 12. So he in fact he gave a very detailed information about what is all about the standard and what is expected from the standard and how could we typically go about implementing those requirements provided in the standard, etc. So I'm not going to repeat any of those since you already have this background, which serves like a very good foundation for my session today. So my intention is mostly towards the practical application of what you heard from Shiva in the last session. So I'm going to talk to you about how you could actually put these things together and start building, developing artifacts with the help of useful tools around you. Now, what's important for us here is to consider is starting with part 3, because part 1 is vocabulary. It's primarily that you read through. Part 3 is for the management and so on. So we are not really looking much of those things because there are limited scope for the tools to do anything there. So we will come here when it comes to the hands-on, starting with part 3 to start with the item definition and then moving on to the hazards analysis, risk assessment, functional safety concept. Then we will quickly see the product development at the system level, hardware level, software level, and then a couple of options on the verification and validation side. So this is going to be the focus for our today's session. To introduce briefly about where do we come from and what's our capability and what's our background about these things. So I quickly take 2 minutes to talk to you about our capabilities on the functional safety analysis. So here, so this capability for Ansys comes through an acquisition of a company called IKV++. It's about 2.5-3 years ago. The company originally was based out of Berlin in Germany, and our only focus in this regard was to develop a solution that supports the complete ISO 26262 process for the functional safety analysis. Now, while we were on this mission, we have had an opportunity to interact with many of our customers globally, including the OEMs, tier suppliers, as well as the engineering service providers. So we have had lots of feedback from our customers, and we use those feedback to address most of the challenging situation that our customers face today. So that's our primary objective. And also, as we move forward, we see that the safety is not only limited to the functional safety of the system, but then you have other domains coming into play, like Dr. Rani was talking about just before. We have the concept of safety of the intended functionality, So here, our objective would be to see something other than the system system that we develop. For example, in this particular case, if we are talking about functionality of the system that we are developing, typically when it comes to ADAS and autonomous application, there are many environmental factors, many external factors that might influence the functionality of the system that we develop. So how could we understand those factors coming from the external world? How could we perform the limitations analysis of our systems, and how could we make our systems safer from the SOTIF perspective is something that's covered under the SOTIF domain. And we have extended our tool capability from functional safety to SOTIF domain as well. And something that goes along with this is cybersecurity, because as you know, today we are talking about connected cars. And when we say connected cars, this could be connection between two different cars or multiple cars on the road, so that they can talk to each other and give their feedback. So can take that information and act accordingly. Or maybe there is a connection between various environmental systems into the vehicles on the street. So when this kind of connectivity options are opened up to the vehicle, it is also kind of an opportunity for somebody who has not so good intention. So he could try and hack into the vehicle, and once they are inside the vehicle, once they have access to the vehicle network, then what they can achieve with that is only limited by someone's imagination. So this is going to create a lot of issues for the people that are going to be using these vehicles, not only the people that are the end users, but also to the other people, other vehicle users, or maybe the other road users, plus the OEMs of the vehicle itself. So this is going to be a very significant consideration from the security perspective. So we also have started expanding the capability of our solution to be able to support you all three analysis in one single environment. Now, of course, you can look into this as an independent discipline, and independently you can start performing your analysis. But what's important for us to see here is that these analysis are interlinked. For example, you want to reduce the risk of cybersecurity, in which case you hope to encrypt the messages that are being communicated with the data bus. The moment you bring in the encryption, so the sender should encrypt the data, receiver should decrypt the data. So that adds to the delay or the processing of your messages, which probably affects the functional safety, your FTTS timelines, and so on. So that means there are linkage between the functional safety as well as cybersecurity, and in some way to the SOTIF as well. So having to perform all of these analysis together in one single solution provides you best of the combination. So that's another area where we are working on. So due to our very focused approach towards safety analysis in the automotive domain, we've been able to acquire over 300 customers across the globe so far, and this is very well adapted by the industry. And now to talk to you about quickly about the various implementation requirements from the functional safety. You already heard in our previous session that we start all the way from the top with the item definitions, and then we have to define the functions of the vehicle, and then we have to start defining or rather deriving the malfunctions with various HAZOP analysis, etc. And then we will move ahead to create the initial architecture of the item. Then we perform the safety analysis on the architecture. Then we are going to derive we're going to perform hazards and risk assessment and derive the safety goal, and then safety requirement, and then allocating these requirements onto the architecture. So basically, if I start explaining the entire flow, probably I'm going to take half of the session just talking about that. So you know there is a lot of activities that are necessary that we have to perform, and we have to generate various proof, various records, various artifacts as a proof to submit to the assessment later in case if we have to. So that means there are plenty of activities that are time consuming and laborious. So this is the current situation with the standard. Now, however, if we go back and see how people have approached addressing this particular challenge, is that many a times we see people starting to get started with spreadsheets. Like most of these analysis, for example, whether it is hazards and risk assessment or whether it is FMEA or different kind of such analysis, are mostly well suited for for table-based analysis. So that means it seems quite easy for us to get started with the Excel sheet. So you define the columns for the data, and then you define probably a couple of macros and computations rules that are defined into the columns, and then you start filling your data. So it looks quite simple and easy to get started with, which of course is the truth as well. It's easy to get started with, but the real challenge is that in any automotive domain, you see that things go with iterative fashion. You start developing the system, and first iteration is developed, and then you will have some new changes coming in. The next iteration comes in, and then whatever has changed between the iterations needs to be considered with whatever artifacts we have developed in the past. So since the spreadsheet kind of the point tools do not provide an integrated approach, we have a significant challenge in maintaining the consistency of the analysis that we have performed. So people might use spreadsheets. In some cases, people have dedicated FMEA tools. In some cases, we see people using different tools for the architecture, sometimes including Visio for the drawing, and different tools for the requirements management, another solution for FTA. And so if you look at this, the whole environment of functional safety is filled with multiple point tools, and these are not talking to each other. And that's one of the very important challenge that we have seen in many customer places. And even though initially it sounds like an easy thing to start with and go ahead, but at some point in time, it definitely feels like a roadblock, because we will be spending too much amount of time and energy in maintaining the synchronization between various artifacts that we develop. And this is precisely the problem that we wanted to address here when it comes to functional safety. So we start with the integrated safety analysis approach, where we start with the architecture model of the system. And this architecture contains most of the information from the overall system perspective. So all the components that are going into the system, and probably the failure modes of these components, how to predict the failure rate for these components. I mean, even though we do it at the hardware level, we could still apply the similar concepts at the various levels. So the architecture is something that keeps all of this information in one single source. And then we start deriving different views from this architecture. For example, when we want to look into the FMEA, which is a specific view of the architecture. For example, FMEA brings in all those components from your architecture plus the failure modes and related information. So it should be easier for us to derive this information from your architecture model, rather than having to start creating your FMEA analysis right from the beginning. And similarly with the rest of the cases, for example, as we start with fault tree analysis, it should be possible for us to relate the fault tree basic events back to the architectural component. So anytime there is a change in the architecture, anytime there is a revision in the architecture, all linked artifacts are going to be automatically updated without us having to manually maintain this kind of connection. So that's one of the very significant advantage. And in addition to that, there are so many things that we have to complete as part of the ISO 26262. So one single tool that's providing you the option to do all of this analysis in an integrated fashion is another very important advantage when it comes to functional safety. Now, it's not only the case about the integrated analysis, but the integration also has to be extended into the organization. For example, in many cases, you might have already decided to go with the requirement tools such as DOORS Next Generation, JAMA, Integrity, and so on. So there should be a possibility to reuse those requirements and then continue with your analysis when it comes to meeting. So we support this kind of integration with requirements. And similarly is the case with the architecture. Even though we provide native capability in the tool to support your architecture development, if you already have decided to use something like, let's say, SCADA Architect, which is of course Ansys solution itself, or maybe IBM Rhapsody or Enterprise Architect or MATLAB Simulink, we provide this integration to be able to import the architectural information from any of these tools into Medini and then extend the functional safety analysis. And one important export capability that we provide in addition is to Microsoft Office environment, especially Excel. So most of these table-based reports can be exported into Excel sheet. So if you want to share this information with someone else who probably doesn't have the tool, this becomes an easy medium for you to exchange the information. So this way we provide one solution that fits very well into your organization and helps you connect various activities that you need to perform from the functional safety perspective. And with that, I close my presentation here. I quickly move on to the workshop part. So just confirm if you are able to see my screen here. So I switched over to a different screen with Medini Analyze. Okay, so I see that people are able to see the screen. So let me continue with this part now. Now, coming to this environment, this is probably something that looks quite simple and easy for those people who already have worked with Eclipse-based environment. So Medini Analyze is a tool that's based on the Eclipse-rich client. So here you have your workspace area. Workspace area contains multiple projects, and then you have diagram area, then properties, and so on. And you have different perspectives at the top, which you can switch over to depending on the activity that you wish to perform. So since for our today's discussion, we intend to talk about battery management system, let's go ahead and start something right from the scratch, and let's look into how could we get started with this and compare analysis. So I will start a new project here. Let me call this BMS demo. And then I'm going to make use of this best practices template, which provides a lot of capabilities, which I will be able to use as I develop the project. I'll explain as we go through this. Now here I have a project that's already been created, and something that you can notice here is the first set is a checklist. So the checklist is something that provides us the guidelines about what to do to complete a particular activity. So let me start with introducing first checklist. Let me call this is my BMS FSC functional safety concept checklist. And if you look into this available checklist templates, we already have this FSC part 3 checklist, part 4, part 5, 6, part 9, as well as including the dependent failure analysis. However, for the moment, I'm going to go ahead with the FSC checklist. And as soon as I have added the FSC checklist, you can quickly see here that the checklist contains various activities that we need to perform to complete the FSC part of it. So the first thing is specify the project properties, and then check and update the operational situations catalog, adjust the task list, and then define the textual description of your item, then define the item functions and define the supporting functions and so on. So there are plenty of such actions that are captured here in my task list. And also, if you quickly look into the last column here, that provides the description, wherein it also explains how you could go about completing this particular task. For example, in the first case where you have to complete project properties definition, so here you have description that says select the project, fill in the custom specific properties for the project using profile tab of your properties view. So this way, if you have a team of people in the organization who probably are not very well versed with the functional safety, or maybe not very well versed with the usage of the tool for this purpose, they have the guidance about what to do and how to do. So it becomes much easier for them to go with this. Now let's start by looking into this checklist itself and start completing our activity. So let me go back to the project here and then go to the properties of the project, and I will start defining the project properties. So here is my project, and here the name of the project. So this is my BMS demo project, and then I have a project description. This is, let's say, battery management system, and the project manager, let's call him boss, and the safety manager, let's say this is safety lady, and the software manager is software guy, and then hardware manager is hardware lady, and then we have QM manager is QM lady again. Right. So this is I mean, I'm just using some funny names here, just to highlight what you can do here. That's just about it. So I have completed this particular job, and as soon as I'm done here, I come back into this field and say, okay, well, now I have completed this job. And you can see that the tool automatically brings up my name and the date and time here. And also something important here is a related element. So if I double click, it gives me an option to select the artifact where I have applied this, or rather completed this task. So for someone that comes in as an assessor at a later point in time, it's going to be quite can see not only the set of tasks that have been completed by the team, He also can pretty quickly see what artifact has been generated corresponding to this task and review that without having to go outside the tool environment. And that's a very powerful feature to get started with the checklist. Now that we have the taste of how we can start working with the checklist, let's look into a couple of other activities that we can perform. So we have to start with the textual and verbal description of the item. So here I have opportunity to go into the item definition, item description. So I have to provide the item description here. Let me call this battery management system, which is my item, and then I can provide the description for the battery management system. So instead of having to type long description, let me just copy paste some content here, and this is my description for the battery management system. And then of course there are plenty of other fields where you'll have to fill in, like what are the legal requirements here. This is ISO 26262 version 2018, and what is the operational environmental constraints, what are the additional specification. There are plenty of other options that you can customize and add over here, but that's not my intention to show you at the moment. But these capabilities exist so that you can capture all the required information to get started with your item description. Now that we have just completed the item description, I'm going to say, yes, this job is now done, and here is my item description, right? So I can complete first part with this way. And now since my item description is completed, let me come here into item functions and start adding the functions. Now, when we look at battery management system, I'm sure most of us are familiar with what are the standard functions of the battery management system. So let me start with some of the top level functionalities. So I just add a couple of functions at the very top level. Let's say one of the functions for the battery management system would be provide battery charge function. Okay. Now, how exactly you're going to define your functions could vary a little different than what I'm specifying here, and don't take it too seriously. It's not the real battery management system that I'm developing here, but I just want to give you an idea how you can go through the process to complete all of this. Now, as soon as I am done with this, I have the other fields here to provide the descriptions and many other information related to this function, which is practically required when you are working on the real system. However, I want to save some time from typing a lot of details here, so I skip those things. Okay, so this is my first function. Then let me say I want to add a couple of other functions. Another function could be provide battery disconnection. Provide battery disconnect function. Okay, and maybe I want to add one more top level function, which could be something like a provide electrical isolation function, right? So the batteries could be very high voltage, sometimes could be 400 volts and so on. So it's important for us to have the isolation from humans. So the three important functions that I have defined over here. Of course, there are multiple functions that I could go on and define, but to save some time, I just limit my functions over here at this level. And then coming down here to the supporting functions, once again, I just want to add few supporting functions. Like one of the important function of the battery management system is to estimate state of charge. So that's one function that I want to put here. And similarly, I want to have another function that gives me estimate state of health. And then maybe I will want to add one more function, and that would be estimate state of availability. Okay, so I just added a couple of other supporting functions, and now of course I can go over here and define the relationship between the vehicle level functions as well as the supporting functions, for which I can create one diagram right here. Let's say I want to add a new diagram here, and I call this function relations. Okay, so in this function relations, I can bring in all of these functions here, simply drag and drop these functions, and then I also can bring in all the related functions over here, the supported functions, and then show the relation between the vehicle level functions as well as the supported function. Now here, if I quickly look into the panel, rather the design palette, I have the capability to show the relation between various functions here. Like, is it like a dependency on the usage side, or is it requirement or whatever? So let's say this is a requirement relation. Now the battery charge function requires state of charge information, and the same function requires state of health information, and then it also requires, let's say, state of availability information. So this way, I'm going to create this kind of relationship between my top level functions as well as the supporting function. Of course, if I were to add additional supporting function, I could show the relation between the other ones also, but for the moment, I stop at this point. Okay, so that's with that we have defined a couple of functions at the vehicle level as well as the supporting level. So that takes me back here into my checklist and say whatever I have completed, let me just indicate them. So specify the item, I have completed the item definition. So coming here to the item functions, so I have defined my item functions over here. So these are vehicle level functions that I have defined. And then below here, I also have defined the supporting functions. Okay, and let me browse to the supporting functions. Okay, and then I also have created the dependency between the vehicle level functions as well as the supporting function. So I provide the linkage to that. And now I have to start with drafting an item architecture. Okay, so I can talk about item architecture development in quite a bit of detail. However, since we don't have much time, so let me start by capturing a simple item architecture for a BMS application. Now, the moment I come here to the item architecture, you can see that my design palette changes to support the development of item architecture. So I can take the item or the system at the very top level, and I just want to create one big container here where I can put my entire application. So this is my BMS. And within the BMS, I believe I will need a controller. So that's going to be my BMS ECU. So I'm going to define a controller over here. Now I will call this control unit. And then let's say I will need a switch box. So I take a component over here and I'm going to define a switch box. And then typically battery is outside the scope of this unit itself, but I just want to show the battery over here. So let me bring in battery also in this diagram itself. Something like this is going to be my battery pack. Okay, so I have made a very top level diagrams, which is my initial architecture of the BMS application. Of course, I can show the communication between the system and the various components. At least let me get started by showing the communication with the external world. So this one is going to carry the messages through CAN bus. So I'm going to define a port here that either sends the data from the vehicle or it receives the data from the BMS application. So that's one port here. And similarly, I have another port that provides, let's say, power at 12 volt for the ECU functions. And maybe I have another port that is ground connection here. So let me say this is power, ground. And then I can make connection between the battery pack as well as the BMS system. So I'll take this here. I don't give a name here for the moment. I just leave it open and just make a connection to my BMS ECU. And here I have a connector. I can use this connector to set up the communication between these various entities. And then I will also have to have a connection between my switch box and my battery pack. So I'm going to set up this connection between these two entities. It went to a wrong place. Okay, I'm going to put it here. Okay. Now I want to set up the communication between these blocks as well. So I'm just going to use a plain connector to communicate between the switch box as well as the battery pack and so on. so on. Also, I need to connect these things into my BMS. So I skip the ports for the moment. I am directly going to connect all of these inputs into my BMS ECU, let's say. Okay, so this is how I could think of a very quick and easy connection for my easy approach to the item architecture development. Now, it's also possible that you show this in terms of graphics. Let's say you want to show this like a battery pack itself. So let me go over to the package here where I have some of the images stored. So I have this battery image and I want to put that battery image over here rather than leaving it just like a black box, right? So this makes it even more visual and it's going to be interesting. So that's how I want to consider creating my initial architecture. Of course, I also need to specify a couple of additional ports for the data exchange to the environment, but for the moment I skip that for saving some time. Okay, so here is my initial item architecture that's already been drafted. So I'm good to go with this. Now, of course, there are a couple of capabilities in the tool to support you if you are somebody that likes to see a little bit of color in life. So let's put this color here. And the functional safety topic for majority of the people is a bit boring. And so let's make it a little more colorful this way. All right, so I have my item architecture that is developed here. And the next thing that I want to do here, or rather before I move to the next step, I also want to briefly bring your attention here to the additional materials possibility. So while we develop this project, it is important for us to have lots of references and the resources that are available. And to collect all those resources and keep them in one place will be very useful to us. Now, when we go into this option, we can add an external link. For example, let's say I'm going to provide a link to the BMS information that's available, let's say somewhere in Wikipedia for the moment, but definitely you're going to put this link to wherever, like, so probably like it could be an internal location. What's happening? So this could be an internal content, or it could be shared on the internet or intranet. So that's up to you. So I just give a location to the URL and say, okay. And since you include such locations, the moment you double click, it should be possible for you to navigate to that page. At the moment, this is going into a wiki page. However, this could go anywhere. This is a URL, as you know. Okay, so that's about adding links here. And if you wish to, you also can copy external document, which allows you to browse to some documents and then keep in the repository of your Medini project. So that way you have all the required resources available in the same place. Okay, so now that we have our item functions, and the next thing that we want to do is to understand what can go wrong with these functions. And typically from the functional safety perspective, we start with HAZOP studies to do that. So here we have a specific place where we can go into HAZOP study and start with this. And this is also called guideword analysis. So let me give it a name, like this is my BMS HAZOP. And then we provide multiple templates once again to choose from. So for the moment, I would like to go with IEC 61882, and let's see how this looks like. Now here, when I create this template, you can see that it comes up with a couple of keywords at the very top. So no or not, which is primarily the negation, then more, then less, then as well as. Actually, if I scroll through, you will see that there are plenty of keywords that are available here. So the idea here is to bring in all of these functions and then pitch them against these keywords and see what kind of malfunctions they help us derive related to these functions. Now, looking into provide battery charge function, which is the top level function, what malfunction can I derive here when I go into no or not? So if I see this, I can simply double click and create a new malfunction, and this could be a no battery provide battery charge function, and when coupled with no, battery does not charge when required. Okay, so that's something I can think. Battery does not charge when required. So I'm going to create one function here like that, and then I can come back here and associate that function in this cell. Okay, so I have one malfunction created here. And mode. So what could go wrong here with the more keyword? If you think about it, battery is charged beyond its capacity or battery overcharged. So when I double click here, I get an option to add this malfunction. Let me call this battery overcharged. And similarly, when I come back to one more function here, let me link it here itself, and less. So I can say battery undercharged. Okay, so this way I will be able to derive the malfunction with the help of the keywords. Now, similarly, when I come back here into provide battery disconnect function, so battery does not disconnect when required seems to be an ideal malfunction that could occur because of this keyword. Battery does not disconnect when required. Okay, so let me come back here and put that into the cell. Okay, and then how about provide electrical isolation function again? So here I can derive one more malfunction, no electrical isolation when required. Or rather, you would always need the electrical isolation. Probably when required is not applicable in this case. So estimate SOC, you can say no SOC data available, incorrect SOC data available, and so on. So maybe I will just do for one and leave the rest here. No SOC data available. Okay, so I have come here and added this into my malfunctions. Okay, so there are a bunch of such malfunctions that we have already created, and the tool allows you to reuse these malfunctions under different cases if that is necessary. So you can simply drag and drop something like, let's say if the wrong estimation is done, the battery is overcharged, let's imagine. So you can simply drag and drop this. If the wrong estimation is done, once again, battery is going to be undercharged, something like this. So this way you will be able to pretty easily reuse the malfunctions that you have developed. So this gives me a fair good idea about how can I go about creating the malfunctions. And now once I have functions and the malfunctions, the next thing that I would be interested in doing is understanding these malfunctions under various vehicle usage scenarios to see what could go wrong and what would be the severity, exposure, as well as the controllability in such cases. And then that would help me define the SL rating for the functions. And then I will move on to define the safety goal, safety requirement, etc. Now coming here to the SL HARA analysis, let me start with the new hazards and the risk assessment. Or rather, before I get here, what's also important for us is to look at the driving situations catalog. So here we provide operational situations catalog like what you see here on the screen, and this is primarily collection of different scenarios that vehicle might be experiencing in the real world, like the different location of the road, different road conditions, different environmental conditions, different traffic and people, item usage, and then vehicle speed or any further situational properties, etc. And then it also comes with the exposure rating and exposure comments for these kind of ratings. Now, all of these that you see over here are provided as an example, which are completely customizable at your end. And I'm pretty sure you have your own set of driving situations catalog. But for the moment, I plan to use this one in my hazards and risk assessment. So let me come here and start with new hazards analysis. Let me call this BMS hazards and risk assessment. You probably would want to do it function specific, but I just want to save some time here by doing it for the entire battery management system. So let me go step by step. So the first choice here for me is to choose from the driving location. The options that we see here are primarily coming from the operational situations catalog, which I have just showed you. So instead of choosing all of this, let me say it is relevant in any location, or maybe there is no impact by the location. So these are the two conditions that I want to consider as far as the BMS goes. So I select them, and the next thing is to choose from the road conditions. Again, I don't think all of these conditions are relevant. So I think any road condition is okay, or no impact from the road condition. And then I move on here from the environmental side. Again, similarly, any environmental condition, or there is no impact from the environmental condition. When it comes to the item usage, I believe it is applicable in all of these cases, so I just leave it the way it is. Then I move over here from the traffic and people. Again, I can pick and choose which of those conditions are relevant in my analysis. Let's say any traffic conditions or no impact by the traffic condition is relevant. And looking into the vehicle speed, I don't think we are going to be around 200 kilometers, so I remove that. But rest of the speed seems to be reasonable for me. I keep it there. And then which of those malfunctions is what I want to analyze here. Let me go ahead and choose all of this to save some time. And now I have option to create a list where tool is proposing 70 entries in one single list. Or of course, you can also choose it based on the driving location or road conditions and so on. But for the moment, let me go ahead and create this list based on all the combinations put together. Now here you can pretty easily see that it captures all the information from our basic driving situation catalog, and it puts them over here in this tabular format. I'm not interested in looking into this operational mode of the item, so I just remove it. And I just want to save some space over here on my screen, so rearrange them. And then you also can see that all the way up to the malfunctions has been captured, and from this point onwards we have to define whatever is the analysis information. So here we come to the hazards. So let's start by defining a hazards list. So here we already have hazards and top level effects. There is a list created, but there is no entry. So let's start by putting some information over here to the hazards and risk assessment. So what are the possible hazards that we can imagine in battery management system? So one of the things that comes frequently to the mind is that if anything that goes wrong with the battery management, typically it might give rise to fire hazard. And this would be very severe as well. And I don't want to type in any description, so just leave it open. Maybe in some cases, we might see that batteries are going to be exploding. Very, very rare cases, but that is a possibility. So I select this one as well. And let's say what else? A typical probability would be over temperature. So I capture this over temperature, and this over temperature is something that's probably a little less severe compared to the other two cases. One more possibility could be electrocution, and this definitely is something that's going to be quite serious. So I put 10 here. Then what else? Maybe loss of drive because the battery is completely discharged. This is not going to be serious, but this is going to be a kind of inconvenience to the driver. Or maybe there is other possibilities like reduced range because the battery is discharged. Again, I put a lower severity for these functionalities. Now, since I have a list of these hazards and the top level effects, the advantage here is that you can create these kind of lists in one place and let everybody use the items from the list. So instead of having to create something by themselves, because usually if you give the choice to different people, they might mean the same thing, but they type it on a different word. So you will have a lot of inconsistencies which can be avoided. Now, in this particular case, I see that the battery does not charge when required. So this can typically give you loss of drive hazard. So I choose this from over here. The potential effect would be the loss of drive, etc. Maybe at this point, I'm not going to capture that, or rather not interested in that. What would be the severity of this one? Probably just S1, not really much serious. So I skip that. I put yes one there, and then the exposure is already provided through my driving situations catalog, and controllability, again, it's very easy for me to manage, and I see that this particular combination gives me quality management level. So quality management level, as we all are aware of, we don't really have to do anything specifically from ISO 26262 perspective, so I just leave it at that level. And coming back here, I have another situation that's called battery overcharge. And if battery is overcharged, typically that could give rise to over temperature situation. And this is usually a bit more serious than the previous cases. And also you have a bit lesser controllability in this case. which gives me a combination of ASLB for this particular situation. And then if I come back here for the other cases, let's say battery undercharge is something I don't want to look into for the moment. Battery does not disconnect when required. This is likely to lead into electrocution. For example, if there is a crash or some unfortunate event because of which battery is supposed to be disconnected, but it does not, exposing the high voltage to the external entities. And if someone unfortunately touches some terminal, that could become quite dangerous. And this particular situation is now taking me into SLD situation. So basically, this is the way how we approach identifying various events that are possible in our system, and what would be the severity of those, what would be the controllability, what would be the exposure. I'm sure you remember the definition of all these parameters that Shiva has explained in our previous session. And of course, I skipped putting my comments over here to the different columns where it is asking me to put this comment. I'm just saving some time, but definitely if you are working on the real project, you are required to put this comment, because it justifies your rationale behind choosing a certain value. If I pick this one, then why do I think it is yes one is the comment in here into this particular field. So now that we have completed this HARA analysis up to this level, then we have to move on to the safety goals and safe states and so on. Now again, for QM, I don't really need to define any safety goals, so I skip. Then for rest of the analysis options, I can go ahead and create safety goal. So let me once again come here and put the safety goals in the right place. So I create a new safety goal here. This one would be, well, I forgot what I talked about, so let me go back. So where did I come from? What was the hazard? Okay, over temperature. So over temperature was the hazard. So let me put the right safety goal. Prevent battery from getting overheated. Okay, so I put one safety goal over here and just leave it at this point. And then there was another SLD situation for which we looked into electrocution. Let's say prevent what do I call this? Prevent electrocution. Let me just put it that way. That makes my job simpler. So I just created a couple of safety goals here at the top level, and then I can make these safety goals against these HARA analysis that I have done. So here, this one. So when I click here, I get this option. Prevent battery from getting overheated, that's my safety goal. And for this one, prevent electrocution is my safety goal. So now that we have completed most of our hazards and risk assessment, I will move on to the requirement side. How do we start managing the safety goals and safety requirements? Now here I have my top level diagram here, and I simply can drag and drop these safety goals over here. And you can notice that these safety goals have SL ratings that are derived from the hazards and risk assessment. So this one is at SLB and this one is at SLD. Okay, now we obviously need to define the requirements to complete this analysis. So we can go ahead and choose the requirements of the appropriate category here. Again, you can see that the design palette has changed to give you options to pick from the requirements at this time. So let me go ahead and pick from functional safety requirement. Prevent battery from getting overheated. This could be something like, let's say, detect overheat condition. Okay, so one of the requirement I put up here as a detect overheat condition. Now you can see that this requirement has automatically inherited the SL rating from the safety goal. So this is how the tool automation really helps. As per ISO 26262 standard, you know that the safety requirements that are contributing to the safety goal should be either at the same or higher level than the SL rating of the safety goal. So now we are at the same level. That should be acceptable as far as the standard is concerned. Now, what could be the other possibilities? Prevent battery from getting overheated. And then let me say, I'm going to put some more requirements over here. Let's say I have to measure battery pack temperature. This is another one of those requirements. And maybe while I'm doing this, I also have to be very careful about the accuracy of the temperature. So let me put another requirement here: ensure accuracy of temperature measurement. So I have added a couple of these requirements. Now you see that these requirements are a bit jumbled up, so I can ask the tool to help me here. So you have this option called arrange all, where tool tries to manage the layouts all by itself. So we have these couple of, we have the safety goal and couple of requirements that have been added here. And then if there is some more requirement that I'm interested here from the electrocution side, so I can go ahead and add a couple of more requirements on this side as well. Let's say in this case, I want to measure battery insulation. That's probably one of the functional safety requirement I could put here. And then disconnect the battery, of course. So that's another important requirement: disconnect the battery whenever there is a crash or any unfortunate event. And maybe also could be something like, let's say we want to measure the battery leakage current. Measure battery leakage current. Now, so a couple of requirements we have added here. So I think you get the idea how you do that. So I'm not going to continue to do this stuff over here. So I just stop it at this level. Now, if you want to highlight these things with different colors, so let's say all of these things are in SLB. So you want to highlight these things based on the SL rating and say these are looking at a little lower at the priority. And I wouldn't call this as priority, but nevertheless, in some way to highlight things. This one is at the highest level. I want to show them in red color. So it's up to you, however you like it. Okay, and now we have a bunch of safety goals and safety requirements already coming up here. And now we will move on to creating our safety architecture, functional safety architecture, and map these goals and requirements into architecture. Now, again, as you have seen, the approach for creating the architecture is going to be pretty similar like we have done here at the item level. So I do not really want to repeat that job. Instead, what I want to talk to you about is the possibility of bringing these kind of architecture from elsewhere. So we have this option called import architecture. So you can get it from, let's say, if you're using Magic Draw, you can get it from there. From Rhapsody, you can import. From Scaled Architect, you can bring it. From Enterprise Architect, you can bring in. From Simulink, you can bring it. And then other couple of options. Now here I am interested in bringing it from Scaled Architect. Of course, the Scaled Architect, if you know, it's a solution from Ansys itself. Now, here is my model from the architecture perspective for the battery management system, which I already have done. So I want to analyze this model for my functional safety analysis. So rather, I consider this one to be imported into my functional safety architecture. So I import this one and choose that I want to get it from my Scaled Architect. Let me browse to the path from where I can get this project. Okay, and here I have my architecture project, and this one is the one project I want to bring in. Okay, so here I have two possibilities to import FSC as well as TSC. So for the first chance, let me just import the FSC architecture. Finish. Okay, so here I have my FSC architecture that's been brought up. So this is coming from Scaled Architect. So let me just reduce the size of this architecture diagram so you will have a full view. Okay, so this is pretty much similar to the one that I have drawn in the past, but it includes a couple of additional things, and it's a little more elaborate on that way. So that's my functional safety architecture. Now I want to go ahead and also import the technical safety architecture. Let's say I want to import from Scaled Architect again. So browse to the same location. It's in the same project. So both architectures are captured in the same project. Once I have this option to pick from the technical safety architecture, this time I'm going with the second option, finish. Now I should have my technical safety architecture now brought into Medini Analyze. So this is the detailed architecture that's coming from the other tools. Now, similarly, you can get in this kind of architecture from various third-party solutions, as we just talked about, which is going to make our job quite simpler in case if you already have been using or have decided to go with some of these tools. Okay, now we have architecture already available. Let's quickly look into a couple of possibilities here at the architecture level. How do we enhance this architecture at Medini level? Now, this is a functional architecture. As far as our design teams are concerned, functionality is most important. So they develop this architecture from the functional perspective. But now that we are safety engineers, for us, looking from the safety angle is something that sounds more appealing. So we select each of this component, and you can see that there is a safety property that can be defined. You can say at what level of ASIL this component is going to be developed. Of course, that can also be done by tracing the requirements, which I missed to show you. I'll come back later. So coming to the failures here, you can specify what kind of failures you might have with the BMS ECU. So you can introduce new failures into this component. Let's say functional failure for the ECU. So that's something that I have added here. And when I come here to the switch box, I can also add a couple of functions. Maybe in this case, relay stuck open is one function. One failure mode, and then maybe relay stuck short is another possibly failure mode. Maybe relay intermittent connection. Okay, so I have added a couple of failure modes for these architectural components, and it's very important as a safety engineer for me to understand what can go wrong with these things, and how do I detect them, or how do I prevent them. So that's ultimately my objective. So I'm trying to do that over here within the architecture. So we will go to the prediction part a bit later. We'll also see rest of the things if we have enough time. I spoke to you earlier in the day about performing the SOTIF studies as well as performing the cybersecurity study, etc. The rest of the fields that you see over here in terms of limitation or security or vulnerability are coming from those aspects. But at the moment, since we don't really plan to look into it, I stopped this analysis at this point. And I also told you that we perform this integrated analysis where model keeps all the information, and then we can create different views, for example, like FMEA, FMEDA, etc., out of the same model. So here, if I right click on this architecture, I get this option to derive FMEA worksheet. So let's create one demo worksheet here. Demo BMS, this is at the architecture level. And as you know, FMEA can be performed at different levels, starting with the function, starting with the architecture, and then to the hardware level where it's going to be called FMEDA, etc. So I'm going to keep this analysis in FMEA worksheet and then create one analysis. Now here you see that there is a cover page where you have plenty of options to pick from. What kind of analysis are you doing? Is it at the system level, component level, function, process, etc.? Then depending on the team details that you can put over here. And you also can notice a couple of presets like VDA AAG combined standard or SAEG 1739, MIL standard 1629. All these presets are available. And then also looking into the options over here. So do you want to show the ports or hide them? Do you want to show the action columns or not? Maybe I don't want to see the action columns. Do you want to hide the measure group information? Well, and then do you want to see the risk priority number, or are you interested in the action priority coming from VDAAG? If you say you want to see action priority, you also have this option to use this FMEA MSR. And then if you are interested in creating FMECA, of course, you go with this particular option. So those are all the options that you have at the cover page. And then we come here to the worksheet where you can see that the tool has automatically brought in all of these components from the architecture, and also wherever I have shown the failure modes. For example, I have added a couple of failure modes into the switch box, and you see that the tool has brought in those switch box over here, failure modes over here. So that's kind of helping me to complete my analysis quite easily. So now from this point onwards, I would rather move to a built-in example to continue this worksheet, because creating rest of the artifacts is probably going to take too much time, and I will just skip that part and move into my already worked out example, so which is very similar to the one that we have seen now. There could be some differences, but I'll focus mostly on the safety analysis side. Okay, now when we are starting with the safety analysis, you also know that there are multiple failure causes and the failure conditions that are possible. So Medini gives you an option to define the failure causes and the conditions. For example, starting all the way from the very basic step, let's say I don't want to see the kind, so I remove it. So dry soldering could be one of the common causes in most of the electronic circuitry. So it could lead to loose joints due to soldering defects, or you might have intermittent connections. You might have joint disconnection due to the cables not connected properly. You might have cracks developed in the printed circuit board, which could create intermittent issues in your system and so on. So you could define these kind of system failures in a list like this, wherein you can maintain the consistency of this list while multiple people are working on it. Similarly is the case with the safety mechanisms and the collection. So here we started with defining certain safety mechanisms that are relevant to our system. For example, like thermal fuse. This thermal fuse will blow and result in open circuit, thus preventing the battery from operated during the high temperatures. So that's quite efficient for me as far as my detection is concerned. I also provide the information about what is the confidence for the typical diagnostic coverage and what is my SPF coverage, what is my LPF coverage can be provided from this mechanism. So this is something that I'm going to use in the future when I start developing my FMEA analysis. So similarly, I have multiple such safety mechanisms that are captured, like triple redundancy temperature sensor, triple redundancy voltage sensors. You have dissimilar algorithms to predict the SOC just to improve the accuracy, software lock to enable the high voltage circuit or disable the high voltage circuits and so on. So there are multiple such things that I have already captured here. So I just quickly wanted to show you that these things are already available in my list, and then I'm going to proceed with my analysis. So coming here, I have created two FMEA analysis. One is the very initial stage when I started working with the function. All my interest here is to see what functions do exist in my project and what malfunctions do exist, what kind of top level effect they could contribute to, what are the potential failure effects, and then what are the potential failure causes. So you see all of these linked analysis that's shown up over here in this analysis. And also there is something called as cause effect net that can be generated from Medini. So starting all the way from the basic thing here, like for example, you have issues with the soldering, you have issues with the cell monitoring, you have issues with the temperature monitoring and so on, contributed by various sensors, which could contribute to the problems at the next higher level, and those problems are contributing to the next level. And if you look at this entire chain from left to right, you could see that all the way from the beginning, issues starting with the soldering effect, finally resulting here up to the top level hazards, where maybe the battery is releasing hazardous gases, or battery is getting over temperature, or battery SOC is not properly measured, and so on. So this way you will be able to see the relation between the causes and effects, and which is very, very powerful to show you this entire view. Now that's about my basic FMEA analysis. I also went ahead and performed one FMEA analysis at the function level with a little more details. So here I once again have the function and the malfunctions, top level effects, the potential failure effects, and I include all these options like what would be the severity of this particular malfunction or the failure mode, and what are the potential failure causes for this function, what is the possibility of the occurrence, and what design control mechanisms do I have here for the prevention or detection, and what would be the detection, what's my RPM number here. And if I go back over here into my chain and say I also want to show the measure group information, it should also bring in the additional column like current design control, prevention mechanisms, and so on. And finally we have this RPM number, and then going ahead I can have revised severity, revised occurrence, revised detection, revised RPM number, and then you also see this risk graphs between severity and occurrence, severity and detection, detection versus occurrence, and so on, which is something that you can also look into from your risk analysis graph. And this was at the top level, at the function level. And as you know, you can perform this FMEA analysis at different levels of abstraction. It is possible for me to perform the same thing at my functional safety architecture. And at the functional safety architecture, you have seen that there are multiple ports, and these ports have failures and etc. So instead of having to do it all by myself, so I just took the help of my previous project. So this is what I was talking here. So you have all these numbers, and then the revised, like your current design controls for the prevention, current design controls for the detection, and what is your revised numbers, etc. So all of those can be brought over here in this FMEA analysis. Again, it depends on the depth of analysis that you want to perform. So if I come here to my technical safety architecture, so all the components from my technical safety architecture are brought over here. I did not have time to complete this, so I left it open at this point in time. Okay, so that's primarily looking into FMEA, and we also can quickly look into the FTA analysis. So the fault tree analysis is something that's very important, which goes as a complementary to FMEA analysis. As we all know, FMEA looks at from the basic leaf level events and then adding up their failure modes and seeing the results at the top level, whereas fault tree analysis would help us looking at the top level undesired events and then find out the root causes that could contribute to that top level effect. So in this case, we have identified exposure to high voltage as one of the top level events which we want to avoid. And here we see that this is happening because of the switch box that is not open in case of an accident. And this could have two different factors contributing to it. For example, switch box is now stuck closed and you have no command received by the switch box. And if the switch box is closed, I just leave it at here as a basic event and forget it. Now coming here to the next part, I want to further analysis like no command received by the switch box, which can be further looked into various other. Let me make it a little smaller so you can see them. Okay, so no command issued by the ECU or the safety mechanism failure. Then this is my safety mechanisms to overcome this problem. And when I come back here, there is a problem with the fault in the ECU, or ECU did not receive the crash informations and so on. So this way I try to do this analysis at the FTA level. Now let's say going back to our architecture here, let's just imagine that we have put some mechanism to support this detection through the crash detector. So this crash detector is a new element which I have added into my architecture, and it includes one crash sensor as well as one crash detection algorithm. And if you expand this, you can see that this includes a couple of malfunctions on its own, not the malfunction, rather the failure modes of this crash detector you can see here. And maybe this crash detection algorithm is something that could contribute to this fault, or maybe the sensor could contribute to the fault. So what I'm interested here is to simply bring in another angle to this one. So I come here and then simply drag and drop this particular item on top of this one. Now you can see that the tool is automatically creating another leg all by itself, and that's helping me to perform the analysis at this level. So crash detection layer failure, and that is contributed due to incorrect computation or maybe delayed communication or loss of communication. So these are the three basic causes contributing to the crash detection layer failure. So this is how I can once again link my fault tree with architecture. So if there is a change in the architecture, if there is a new failure mode being added into crash detection layer here, that would appear over here in my FTA analysis as well. So also see, for example, if I right click here and say show me all the related elements, it represents the delayed communication. So you see it gets highlighted at this level. So that's pretty powerful. And now to prevent this, you may also be interested in let's say creating requirements. So you can say derive requirements from this particular basic event. Now this requirement I want to sit here in my safety goal and requirement. So now you see this is automatically added by the tool into my overall safety goal. So if I come here to this requirements tab, I can see loss of communication is my requirement. So obviously I have to complete this requirement, but the tool is just giving me an opportunity to link all of these things together to support an integrated analysis. So that's how I go about performing my fault tree analysis. And of course, to support couple of additional insight from the fault tree, you can ask the tool to perform your fault tree evaluation. You can specify the mission time for this fault tree and let it compute the cut sets as well as the various numerical output that you are interested. Like for example, here you can see the unavailability data, probability function distribution, PMHF data, and then PMHF computed with different methods. and so on. And below here, you see the set of cut sets that are generated. When you see single point event here, this is a single point fault that is possible in your design. So if you want to see this in the tool, you can just ask the tool to show this to you. Now here you can see that this entire path is highlighted. For example, the switch box being stuck closed is going to contribute to the switch box stuck closed one leg of this OR gate, which is finally resulting in the violation of our safety goal, which would lead to exposure to high voltage. And similarly, if you look at this, there are dual point faults. So if you ask the tool to show where exactly these are, you can see it starts from the top over here. It comes like this here, and then it's moving to the right side. So since we have an AND gate over here, both my command issued by the ECU as well as my safety mechanism should fail to contribute to the violation of this top level goal. So that's how tool helps you in both performing qualitative as well as quantitative analysis as far as the fault tree is concerned. Now, quickly, I want to take you into the FMEA part where we can perform this hardware analysis. Again, I did some shortcut here since I did not have enough time to do all this by myself. So I moved over here into another project where this is already done. So coming here to my diagnostic coverage side, so I already have this diagnostic coverage worksheet that's prepared in this particular case. So you can see the details of this DC worksheet where I have all the hardware components that are necessary for implementation of my BMS hardware are brought in here through import of bill of material. I'll probably go back and show you that in a moment. But you can see that the tool has helped me compute the failure rate of this component. And then you have a question here. Is this particular component related to the safety analysis or not? If you say yes, then you will have further analysis enabled. If you say, well, this does not matter to the safety, then you remove it. Now here you see in the metrics, total failure rate is so and so, total safety related failure rate is so and so, and then total non-safety related failure is so and so. And also you can look into the single point fault matrix as well as the latent fault matrix, and it gives you the numbers. Like currently we have 99.7%, whereas what is expected is 99%, so we are in green. And similarly, when it comes to the latent fault, we are expected to have greater than 90% coverage, but we already have 99%. Again, that's my analysis, so it is making my life easier. For you, it could be a bit more challenging. Now, quickly looking into here, various options that you could look through, like the potential failures, related fault tree event. Now, the related fault tree event is like what we have seen in the past. When you link your architectural components with the fault tree, or when you link the hardware components with the fault tree, you see that entry coming up over here. And then what are the top level effects? What is the failure rate distribution? Like when you have a component that can have multiple failure modes, you can even distribute the overall failure rate between the different modes of failure. For example, when I'm talking about a resistor failing open is much more frequent than it failing short or losing its tolerance. So I can say for 90% of the time, resistor fails open. For 10% of the time, resistor drifts from its tolerance. So that way I can split the overall failure rate across the different modes of failure, and then I can answer a couple of questions like, does this failure contribute to the violation of the safety goal? So this is the question here. Does it contribute to the violation of the safety goal? If you say yes, then you have to continue with the rest of the things. Otherwise, you can say, okay, this is not really relevant to the failure, my safety analysis here. And then you have a question about next question here. Does it contribute to the this one is for the single point fault, and this one here is a question for multi-point fault. Does it also contribute to multi-point fault? Then you can select it over here. And then there are questions about what is your safety mechanism to detect this? What is your safety mechanisms to prevent this? What is your confidence in your safety mechanism, based on which you get these numbers? For example, if we are looking into this one, so we have the failure rate at 0.876 whatever, and after the 99% confidence, what remains as a latent fault is 0.0087. So now the tool is going to add up all of these numbers to give you the metrics below over here, like you see at the bottom of the screen. So this is how we perform or support with the diagnostic coverage analysis in this environment. Now, quickly talking about various failure modes and the failure rate prediction, just another 5 minutes, I'll close that topic. So here in the hardware architecture model, So we have this what's called as hardware parts library. So today Medini does not come with its own parts library. Rather, we create a part library by importing the components from your side. We probably can cover that detail to those that are interested in that topic, but I just skip that for the moment to save some time. However, quickly what I wanted to explain is how exactly we can introduce the failure modes and the computation of the failure rate for these components. So now here we come to the prediction tab, and when we are in the prediction tab, we say we are dependent on the catalog to compute the failure or rather estimate the failure rate of this particular component. And Medini also comes with the built-in set of catalogs. As you can see over here, you have IEC 62380, CMOS NOM 29500, Mill Handbook 217, and then 217 Plus as well. Then you have FIDES guideline. We recently added this GJB 299C, which is to support our Chinese customers, and then 61709, which is a recent version that we have added here. So you pick the right catalog for your analysis, and then go through the right kind of selection for the components, for the category and subcategory, and then the type of the component, and then the manufacturing style, the different packaging as far as the integrated circuits are concerned. And then finally, when you made appropriate choices, you also can quickly look into the expression that tool uses to perform the failure rate prediction. And then we also can see quickly here the support for mission profiles. So for those catalogs that can use mission profiles, we already have an example mission profile provided here. And of course, you can develop your own mission profiles and apply them onto your entire electronic circuit, and then ask the tool to give you the prediction. So here you see that tool gives me a number here like 9.17 whatever. So this is the failure rate that is predicted from this component. And of course, there are other capabilities to help you with the scaling, etc., which probably is not interesting at the moment. I'm not talking about all of those things. And here also you can see the failure modes of these components. And when you import your component through the bill of material, like for example, this is one sample bill of material that you can export from your ECAD software after having your electronic circuit design. So it's highlighting the circuit block and your reference ID, part number, and so on. So, and you will be able to import this to create your hardware architecture, which is what I have done over here. So it's my ESL architecture over here. The different classification of the component and different instances are all brought over here. And then finally, I can compute the overall failure rate of this block by right-clicking here and going into the prediction and say recompute the failure rate, and the tool will do that job automatically. I probably missed out something, so I see some error. I'm not interested in fixing for now. But when you see your FMEA worksheet, you will get all those numbers brought in by the tool. And pretty quickly to go into the dependent failure analysis as well as the support on the software side. When it comes to the software safety, I once again created a checklist here. So since most of our analysis is based on the checklist, so I captured some of the important activities that we need to perform from the software side. For example, software code inspection, code static analysis, then static typing, no dynamic memory allocation, rule violations, and so on. So I have multiple such rules that are captured here, and then I have provided the justification as well as remarks. So perform the source code inspection, and then typically, since we provide tools also for the software development, you probably have heard about a tool called Ansys SBU, and that comes with the qualified code generator. So that means you have a that the code that is generated through KCG is correct with regards to input model. So it avoids a lot of activities that we need to perform at the lowest level. And so it proves to be very, very useful when we are developing applications such as BMS. So I use that to help me with the software code generation. I'm not getting into the tool because that's not the focus of our topic today, but I quickly wanted to explain that all of these metrics can be generated through automatic code generation and the related supported capabilities in the tool. So here I have a requirement to generate static analysis on the tool. So I can simply come back here and say, show me this in my model. So the tool should highlight this in my workspace. And when I open this metric, it should give me the data about all of this. So here you see the tool is giving me the data about the maximum members in a single structure, number of dimensions for an maximum whatever. So you have plenty of such parameters that are automatically generated through the tool. And then you have this document that explains how the functional safety compliance is achieved through automatic code generation. And this is a document that is certified, the technical document supported by TÜV analysis. So you have a detailed information about how do you trust that the generated code is compliant to safety standards and so on. And then I move on here to the various other parts, like for example, the test results. So this is my cell voltage analysis component for which I have the test results that are captured here. And again, you can see that the complete test information of this project is captured here. Multiple number of tests that I have done, the expected results, the actual results, the results, the report of test execution is all captured here in this documentation, which is once again going to make my job much simpler and easier when it comes to the software part of the story. And finally, SAEINDIA application also requires model coverage. So for that, I have a coverage report here. So this is also automatically generated from the tool. So here you can see that it provides me the complete coverage report, all the way including modified condition decision coverage. And then you can have this kind of report generated from the tool that tells you how much part of your model has been covered, what is not covered, what is justified, and so on. So this is some way we have support for the software part of the story as well. And the last part here is the dependent failure analysis. So coming to the dependent failure analysis, I once again do that with the help of a checklist. So I can add a checklist and start with the dependent failure analysis. Here I already have this checklist, so let me open up here and show you. So again for DFA, we have captured lots of activities where you probably can have coupling between different parts. Like at the system level, if you have used the same power supply as a source for two different sensors, then that's a problem. So you have to analyze this part. Similarly, at the component level, if you have used the common library functions or common calibration parameters, that could be an issue that you need to look into. At the hardware level, if you have used a common clock for both the microcontrollers, again that could be your common issue. And similarly, we have multiple such possibilities for the commonalities that are captured here in the DFA, which you can systematically analyze and understand the impact. So that's probably what I wanted to talk to you about this quick workshop on the BMS. So let me now move back to my presentation and conclude the session. So we have looked the entire capability of a tool, that how a tool can help you in terms of development of your functional safety for any application that you take up. I just took BMS as an example. However, we know the same process is followed throughout our development process. We have looked into all the capabilities that are supported in one single environment, also to support an integrated analysis across the various artifacts, and to completely support the required capabilities that are necessary for the ISO 26262 compliance, all the way starting from the item definition or supporting the architecture, supporting the requirements, supporting the FMEA, FTA, then FMEDA, multiple field rate catalogs, and then DFA, and import export capability. So you have seen all of it. And of course, one part that I missed is there is also support for document generation from the project. So you can export the document into Excel, or you can generate an integrated documentation that includes all the diagrams plus the table-based reports, etc. If you wish to share across different stakeholders in the project, well, that is also supported. And we have integration with the tools such as task management solutions, such as configuration management capabilities, etc., on top of what I have talked about. So probably for those of you that are interested in this discussion, we can talk separately on this. So that brings me to the end of our talk today. I think I already took some 15-20 minutes more than allotted to me. With that, I would like to thank all of you for taking your time off and joining the session today. I hope whatever I spoke today was useful to you. And at the same time, I would like to sincerely thank organizers for giving us this opportunity to present this to all of you. Thank you, everyone. If there is time, I could take questions, or otherwise I let the organizers continue with that.
Participants, if you have any questions, please unmute yourself and you can ask the question to Mr. Raghavendra.
Raghavendra, good evening. This is Yogesh here.
Good evening, Yogesh.
Yeah, so we just put a light on DFA analysis, especially the hardware DFA analysis seems to be very much easy. But if it comes down on software, what are the parameters or what are the metrics we can use?
Yes, maybe in our analysis here, we have this worksheet, or rather the task list that captures some of this. Let me see, what do we have for the software? Okay, so this is primarily coming from part 9 of the standard, shared information as it knows it is okay, that's fine, environmental influence. So I think in all of these, both hardware and software are considered together. So in the first topic, if I see at the software level, the possibility of the shared resources are in terms of common libraries, calibration parameters, etc. And then coming to the shared information input, when it comes to the software, this is typically the global variables. And then environmental factors, there is nothing that can influence software. System coupling, when it comes to software level, mounting and connection, no, that's not the one. Software level, probably you are using the same algorithm at different level, that's not providing you dissimilar computation. At the component level, once again, the libraries that are common across different computations. At the communication level, I think there are some details provided in the ISO 26262 standard. I haven't read through that, so probably I will look into that a bit later. And other aspects, again, are referring back to the ISO standard. I think these are the ones that are recommended or advised by the standard, which are captured over here. So typically, when it comes to the software, we see that the challenges are in terms of libraries. The common library functions, they easily skip out of our attention because they are not visible to us as far as the architecture is concerned. That's very likely to cause our common cause issues, dependent failure issues. And the other thing is the usage of shared memory and the usage of global variable, and such things are once again providing the dependency between different components of the software.
Okay. Thanks, Raghavendra.
Yeah, sure. Any other questions?
Hi, Raghavendra, Rajesh. One question regarding the reusing the complete this workspace for a smaller variant or a delta changes which comes after my project is closed. So how is it possible to reuse it with a different shape, or how can you handle this in the tool?
Well, that's again an interesting question. So we support what's called as project derive. So when you come here, you can derive a project based on the one that you already have done. So this way, all the artifacts that you have developed in the previous project are going to be reused in the new project, and then you can enhance by making whatever small changes that you need to do in the different variant of your project. Not only that, when it comes to the architecture, etc., we support this variant generation. Let's say it's not strictly speaking variant, so I'm not very comfortable to call it by that name, but you will see that there is an option to derive the variants from this. So this way, if you want to use an existing artifact and reuse them in another project, that's possible. And in addition to this, we also support diff and merge between different versions of the project, or maybe between two different projects. Now, like for example, if I choose two different projects here, I should be able to see the options. Like if I right click just here, you don't see any such options for diff and merge. But if I select more than one, and the immediate option here is to see compare with each other. So this way I will be able to bring in those artifacts selectively into the project that I'm working on. But however, something that's important for us to keep in mind is that Medini works in an integrated fashion. So that means it tries to link the artifacts to one another wherever it is possible, wherever it finds an opportunity FMEA tooling, it does that. So if you are bringing in an artifact wherein you probably don't understand the explicit relation between that artifact versus rest of the artifacts in your project, when you do this kind of migration or when you do this kind of merge, the original artifact will be brought in, but all the dependencies will also be brought in to keep the synchronization of your whole project. So this way, tool once again tries to make sure that you're not missing out on something, but at the same time you get the opportunity to reuse whatever you have worked on earlier. Thanks.
Raghavendra, this is Jairam.
Hi, Jairam.
When you are doing FMEDA in the diagnostic coverage sheet, so is there any possibility to select a safety goal, safety goal wise, or violation of safety goal wise, or we have to select? We can only select all the safety goals violated.
No, the FMEA or diagnostic coverage analysis that you develop is dependent on the safety goal that you are referring to. So it asks you to provide the safety goal at the beginning, and based on that, it determines the metrics that you need to comply with.
Okay, in the FMEA worksheet, if you see, so there is a checkbox for all the safety violation of safety goals. So if we check that box, it is considered to be selecting all the safety goals. Or
yes, it is more relevant to DC sheet rather than FMEA worksheet. Like you said, I agree that in FMEA it includes all the components, but when you do DC coverage or the diagnostic coverage studies, where you get additional capabilities in FMEA, you will be looking into the failure rates alone, failure rates plus the failure rates that are related to the safety, for example. But beyond that, there are no columns to indicate whether a particular failure will contribute to a single point fault, or does it contribute to latent fault, or do you have safety mechanism. So these options are built into diagnostic coverage sheet. So typically, if you are interested in these metrics, and then if you want to analyze coverage for the safety goals, I would say you will go with the diagnostic coverage.
Hi Raghavendra, this is Abhishek here.
Hi Abhishek.
For the tool, actually, when once complete the billing is complete, is there any process also available for reviewing complete things that we did?
Yes, we typically use checklist for this purpose. So when I talked about the checklist at the beginning, our objective is twofold. Is that the checklist help us in directing our team through the process, and the second thing is the same checklist are going to help us through the assessment part of it also. So as an auditor, my intention would be to see whether you have followed all the process, have you generated all the artifacts that are necessary as a result of following that process. However, if I enter in here as an assessor, my interest would be to see the correctness of your artifacts as well. So this checklist gives both the possibilities. I can look through the process that you have followed, and I also can look into the artifacts you have developed and quickly understand whether these artifacts are correctly done or not. So that way, I believe the checklist can address both the questions.
Got it, yeah. Thank you.
Sure.
This baselining of the complete structure. So what is the baselining approach which you recommend if you use this system? So whether it is a system, software and hardware, how do you want to baseline it and link it across the baseline? Is there any approach towards that?
Well, this is one area where we are spending a lot of time on the R&D today. So we have a roadmap for what we call as Digital Safety Manager, which is going to be built on top of Medini, where we want to be able to support all of these activities natively. Today we do that with the help of configuration management. However, since we followed this integrated approach, there is a little difficulty to specifically manage individual artifacts. Let's say it's not possible today for us to manage FMEA independently or FMEDA independently, because all of these information that you find in the sheets are also linked back to something else. So managing the configurations of individual artifacts is a little difficult. So we have to do at the project level. But definitely the question that you brought up is very relevant, and we already started working on it. So I hope in the future we will have a very robust solution to address this particular challenge as well.
Thank you.
Sure, thanks.